Yo people, what's up? Well, I know my intros are pretty boring, and trust me, we both agree on that. So let's just jump into it. PAM is a personal assistant that I created using Python. It's just basically a bunch of if and else's. So it's basically an if and else bot, which is pretty much what AI are nowadays, and it works on voice commands. What it does is basically speak, and then it takes the speech, it records it, and it runs it through a speech to text API provided by Google, and then the text generated by it is run through a parser, regular expression parser. And in my code, I've specified in some if and else's what to do when this particular keyword gets matched with the text that got generated with the API. So it's pretty basic, and I'll give you a brief explanation as to how it works. So here's a brief explanation of what happens behind the scenes. So basically I speak, give a voice command like open a terminal. Then voice, or basically the audio, is given as input to the Google speech to text API, which then generates a string which basically has the words that I spoke, and I then provide this string to my dump code. I'll explain that all the code and all of the if and else later. When all the stuff is done and all the jobs done, you need to know that your job has been done, and your that PAM has received the order and stuff. So what I do is I send a notification on the screen. Plus, I actually call a function which uses Google's text-to-speech API, which is actually the reverse from here, which converts text to speech, and then I make my computer say stuff, basically, like, Jarvis. Now, you might be wondering, why should I not do all of this manually? Why should I not just spawn terminals manually instead of giving program voice commands just to open them? Why should I not just go to a new workspace to open Firefox, and if I want to do anything in Firefox, just enter the website name and just go ahead? Well, because I'd rather go make myself a sandwich with that 0.5 joules of energy that I can save by not typing all that bullshit. So yeah, I made this program to basically make opening stuff that takes more than one step easier and faster. So yeah, this is just a lazy excuse. So I'll show you a demo right now. Please increase the volume for this, because it is an old recording, and my mic wasn't that good back then.
こんにちはご主人様。
Open a terminal. Open Reddit. Stop listening. Stop listening.
Sayonara Zanark.
So that was a demo, and now I'll explain all the code, all the stuff behind it, how it runs and stuff. Let's get this terminal out of the way. So this is the code. Okay. How I run the program is basically I have i3 window manager in on my Linux distro right now. So in my i3 config, I have specified that if I press mod 1 plus P, here mod 1 is alt in my keyboard. If I press alt plus P, then it will execute this file pam.py. Home Zanark, this is the path to the file. If I press alt plus P, it will execute pam.py. So this is how I run the program. And here pam.py, I use speech recognition, which is a really good library for speech recognition, and I imported all the functions that I have created in PAM work. So R is an object of class recognizer from the library SR recognition, and mic is also an object of the class microphone. I use these two objects to do all of the stuff. I set the dynamic energy threshold to false and the energy threshold to 400. This is basically so that when I use the mic, it only records the voice that's loud enough for an input and does not record any background noise. So when I start the program, it first speaks this, which sounds like this.
こんにちはご主人様。
Then it enters a infinite loop with mic as the source. It then adjusts for any ambient noise that might get recorded, which is ambient noise is basically any background noise, and then it records the audio from the mic. The timeout is set for 4. That is, if for the first 4 seconds it doesn't get any audio, then it will stop listening. And the phrase time limit is also 4. The tasks function is inside PAM work, and I'll explain it later. What it does is basically it sends the R recognizer object and the audio which gets recorded from the mic to this task function, and that's it. And this continues inside a loop. So this is where all the meat of the program is. I'll explain this now. So I imported some libraries. For the first is speech recognition. Speech recognition is basically used for recognizing what is being said inside an audio. PyAuto GUI, I use this for sending keyboard signals. RE is basically a library used for regex operations. Subprocess is used for bash commands. It's like execl and C. Time is used so that I can halt the processing for some seconds. System is used so that when I say stop listening, then the program will stop. It will terminate completely. GTTS is the Google text-to-speech library, and it uses the Google text-to-speech API to convert text to speech. OS is used for file location and handling all the files and stuff. And here I'm using PyDub to increase the pitch of the audio that gets generated from GTTS so that it sounds cartoonish. So there's this file location global variable which basically will have the location of the PAM work file so that I can easily access this assets folder and all the files inside it. I'll come back to speak. Let's start with tasks. Tasks is basically a function which takes R, the recognizer object, and audio, the audio which gets recorded from the mic, and the whole thing is in a try catch block which generates 2 type of errors. Unknown value error, which is basically when it is unable to recognize the speech or recognize anything that's being said in the audio, and this is a request error, which means that program wasn't able to request anything from the Google Speech API. Inside the try block, I first create a result string which basically has the text that gets recognized using the recognize _ Google function. It takes the audio as the argument, and it here uses the Google speech to text API, and it then generates a string which has the text. Then I run a notify send command, which is basically a program in Linux which you can use to send pop-up notifications on the screen. Then I created a variable x which stores all the keywords that get matched with the result. Here, for example, this part of code is for opening a terminal. So if the find all function finds any keyword that gets matched with anything in the result string, then it will store it in X. That the part of this result string which got matched with any of the keywords, it will store it in X. Then if the length of X is greater than 0, which means that if something got matched, then it will do the do what's specified here. Basically, in I3, if I press Alt and Enter, then it will open a terminal like this. So here I using the key PyAuto GUI library, I use the key down function to press and hold Alt, then I press Enter, and then I release Alt. This way, terminal gets spawned. Similarly, the other functions. This here is how PAM stops when I ask it to stop listening. It basically searches for the keyword stop listening, stop, or terminate in the result. It will ignore all the cases. It checks whether it found any thing matching the keywords. If it did, then it will send a notification that goodbye Zanark. Then it will speak sayonara Zanark
さよならザーナーク。
in a Japanese voice, and then it will stop. The program will stop, system exit, and it will display this on the console if I run it from the console. This is basically for debugging. So that's it. That's all the meat that was inside the task function. This speak function here is basically used for converting the text to speech, because where you need to know that PAM heard you and it did its job. So this is kind of like a notification as well. So I create an object TTS using the GTTS class, and then this sentence is basically what I want it to speak, and the language is basically the language that GTTS will use for the text to speech API. I then save that audio which I get from the API. I then convert it into a wave file, because for PyDub to work properly, I need a wave file. Then I use the wave file and increase its sound frame rate. When I increase the sound frame rate, the pitch of the audio also increases automatically, and therefore it kind of sounds cartoonish. So the new high pitch sound is basically a new audio with a increased frame rate, and then I export it into a new audio file, AUOP high pitched wave, and then I play that audio file, and I then delete all the source files source audio files that I were used to create this high pitched audio file, and that's it. That's all this PAM work function does. So that's it, and I have uploaded all the code on GitHub, link in the description. So as you can see, I have a lot of stuff that I have yet to do and complete, like stuff like play voice on different thread, which is basically the GTTS stuff, and the job that needs to be done will be on different threads, so that the overall performance gets faster when the performance increases basically. So there is a lot of stuff that I'm thinking of doing, like a web app where users can make their own custom AI. So basically it would be like Scratch, the programming language Scratch, and people will just drag and drop their tasks, and then the website will create a Python file which will have the AI. So I'm planning to create all of this stuff. I don't know if it's a good project, but I just want to make it better. And feel free to send any PRs if you want to. This is open source, of course, so I'll be really glad if someone could help me out and all of this stuff. So that's it, and here's a nice treat at the end.
こんにちはご主人様。
What do you think about my college?
ITAR का माँ कब हो गया